All right, so we are at lesson 4 of unit 1, and you'll notice that in the lower third here it says 4A. Now, there aren't going to be 2 videos. I'm actually going to keep everything within one video so nobody gets confused or loses track of what's due by our next class. But I am going to break the video into these 2 parts, 4A and 4B. So when you see the 4B section come up, if you'd like to pause the video and take a break before you keep moving on, that's fine. This isn't going to make it overly long. It's just that there are 2 very separate sections of this lesson that I want us to consider, and I just want to make sure that in our notes we make a nice break so nobody gets confused. So that's the plan. That being said, this first section is about the quadratic formula, which I'm pretty sure most of us have at least used at one point in time. So let me write it here, just in case you're trying to remember what the quadratic formula is. So the quadratic formula is frequently taught at the end of Algebra 1, and we sometimes use it in geometry a bit. And it says that if you have a quadratic equation of the form ax squared plus bx plus c equal to 0, we can solve for x in this situation, which we know usually yields at about, well, I should say, it usually yields 2 solutions. It's not necessary that it has to yield 2 solutions, but in our experience, it frequently does. So we need a formula in order to solve this that's going to give us the possibility of more than one solution. So if we have it of this form, then we can solve it using the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, when we're talking about b and a and c, we're getting those numbers from our original quadratic equation. A, B, and C. A and B are the coefficients of x. It doesn't include x. So if this was like 2x squared plus 4x plus 3 equals 0, A would be 2, B would be 4, C would be 3. It wouldn't be like A is 2x squared. A is 2. It's just the number, just the coefficient. Okay, so that is the quadratic formula. Hopefully that sounds vaguely familiar. If you've forgotten how to use it in a practical sense, that's okay because we're here to review it. But my point today isn't to reteach all of the quadratic formula in the video, but I want to show you where the quadratic formula came from. And in fact, it's related very, very closely to our prior lesson about completing the square. So you may have noticed that when you're completing the square, whether it was in the video lesson or in class, every time we complete the square to find solutions, we go through a very predictable path of steps. It's like we move the unnecessary numbers over. So that would be like the ones place or any coefficients of x squared. We move those away. Then we take the box and say, what would this be as a square? Complete the square. Then we turn it into the factored or the squared form. We square root both sides, we get a plus or minus, and we break it into 2 pieces, and we get a solution every time we follow those steps. And in mathematics, whenever we have a very predictable pattern that we find ourselves doing over and over and over again, you'll find that there's usually a formula of some kind that has been developed to give us a shortcut. So a formula is just a generalized way of solving one type of problem the same way every time. And it always works, which is why we like the quadratic formula so very much. So let's do this. Somebody along the line said, hey, if I'm completing the square the same way every time, maybe I could take the completing the square method and come up with a formula. So they started with this form, ax squared plus bx plus c equals 0. And the reason they came up with this form is because it represents any type of quadratic equation in its standard form. So even if we had missing pieces, like x squared plus 81, we could say that there are 0 x's. Like we still would have an x term, it just would be a 0x term. And that's something we've done in class as well. So every quadratic equation fits this form. So this is what we do. We say, let's perform the first step of completing the square on this very vague symbolic example of a quadratic equation. So the first thing that we do is we take away the ones place, which is like the c. Now, I do want you to follow along with this and write this in your notes, but you're not going to have to reprove this later on, so just enjoy it. What you're writing is just to make sure that you are appreciating what we're doing here and the value of completing the square and how it helps us understand the quadratic formula. But no, you're not going to have to prove this on a test for me. Maybe if you're in honors. We can talk about that if you're in honors. Okay, so we move the ones place. We also need to move this a because we don't want to try to complete the square when it's not necessarily a square number. That would be very confusing. So I have to divide every term by a, which means that I end up with x squared plus b over a times x plus something that we're going to try to figure out equals negative c over a. Now you know why I warned you ahead of time that you're not going to have to redo this because that looks pretty ugly, doesn't it? It does have to get worse before it gets better. Let me copy this thing that we just created here to the top of the next page. So x squared, I'm just rewriting it, plus b over ax plus something equals negative c over a. So we said in class when we're trying to complete the square, we have to kind of use our block form. The x squared block is over here. The x's need to be divided into two equal groups. So that would be half of the x's. So we'll actually call that 1/2 of whatever b over a x's is, which is, so this would be, have a dimension of 1/2 b over a. So we'll call that b over 2a x. By, this would be b over 2a x's. So x plus that and x plus b over 2a. Which means that our ones place here is going to be the dimension of b over 2a times itself, b over 2a. That's the type of ones. So let's say if b over 2a was 4, then it would be 4 times 4, and we get 16 ones. If b over 2a turned out to be 3, then it would be 3 times 3, and we'd have 9 ones. But basically, we don't know what it is because we're doing this completely symbolically. All right, so I'm going to do a little fun math here. B times b is b squared. 2a times 2a is 4a squared. So we are adding right here the term b squared over 4a squared. Of course, if I do it to the left, I have to do it to the right. Aren't you so glad you're not going to have to redo this? Just so crazy. By the way, also for the honors, don't feel like you're going to have to redo this either. I may ask you a question on the test that says, hey, can you explain how the quadratic formula came to be? And you could explain it to me in words, but I'm not going to expect you to do this all out. Just want you all to not panic. Okay, so these are our 3 terms of our square that I just completed. I want to rewrite it in terms of its length and its width, which we've decided is x plus b over 2a by x plus b over 2a. Very simply, I could write that as x plus b over 2a squared because it's the same dimension. And over here on the other side, I kind of want to put these together, so I'm going to give it a common denominator, which we haven't even reviewed this year, but if you recall, whenever you want a common denominator, when you're adding fractions, you just have to multiply the top and bottom by whatever's missing. So I'm going to change this into a fraction that has 4a squared in the denominator, which means I have to take I have to put 4 up here and an extra a. So it's negative 4ac over 4a squared plus b squared over 4a squared. All right. This is pretty awesomely ugly, isn't it? But I'm just doing the quadratic formula here, so that's okay. I'm just going to erase this because I need a larger eraser. It's okay. There we go. That's the way I wanted to do it. Okay. Back to writing. Let's use green. The green will stand out here. So I'm going to leave this alone on the left. I just changed the pen width. Hope that doesn't stress anybody out. equals, I'm going to combine these because they now have common denominators. So this is negative 4ac plus b squared over 4a squared. Now, again, if you are familiar with the quadratic formula, you should be starting to see some things that look familiar. B squared minus 4ac. Where did we just see that? Let's go back here. Right here, b squared minus 4ac. We're not quite there yet, but we are starting to create an equation that looks awfully familiar. Okay, let me rewrite it over here. So we now have x plus b over 2a, this is the dimension of our very strange square, equals, I'm actually going to rewrite that as b squared minus 4ac, just because if I'm adding two terms, negative 4ac plus b squared versus b squared minus 4ac, it's the same thing, I'm just rearranging their order, just because it sounds so familiar to us. Now we're going to take this opportunity to square root both sides, because I have a square here, and I need to undo it in order to solve for x. I'm trying to get x by itself in case we had forgotten what we're doing here. So I'm going to take the square root of both sides, but remember when we undo a square, we need to always make this little caveat here that it could be positive or negative. We don't know if our original answer was positive or negative, so we need to take into account that either one is possible. So this cancels the square. I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Now, for those of you who remember the quadratic formula, this is getting awfully familiar, but we're not there yet. In fact, x is not by itself, and also I have this 4a squared in the denominator that happens to be a perfect square. When we're taking the square root of a fraction, again, this is me throwing out a whole bunch of things that we haven't reviewed this year, but you might remember when you take the square root of a fraction, like the square root of, let's say, 2/4, you can split that into the square root of 2 over the square root of 4, where we're actually separating the square roots. And it's not that this one is more or less correct or this one is more or less correct, but the second method gives us the opportunity to see that I have the square root of 4, which is a number I can take the square root of. Square root of 2, not so much. I'm kind of stuck with the square root of 2. But the square root of 4 is 2, right? 2 times 2 is 4, so the square root of 4 is 2. And so we have an ability to make that look just a little nicer. Well, we're going to use that same kind of rule. I'm erasing it because it has nothing to do with the quadratic formula. But I'm taking the square root of an entire fraction right now, which means that I could split it into two pieces. I could take plus or minus the square root of the top divided by the square root of the bottom, which, oh, I erased the squared. There was a squared there. I think I erased it when I was undoing things. So the square root of the bottom, which was 4a squared. That is a perfect squared. 4 is a perfect square number, so I can square root it and get 2. A squared is a perfect square number. I can just get a. And I can't really do anything about the top, kind of like when I had the square root of 2. I'm still stuck with b squared minus 4ac. Oh my goodness, we're going to need more space. But at least the denominator is simplified. And in fact, look at that. Plus or minus the square root of b squared minus 4ac all over 2a. Where have I seen that before? Oh my goodness, it's right here, right? Surprise, surprise. Right here. Plus or minus the square root of b squared minus 4ac all over 2a. We're only one step away, well maybe two, from getting our full solution. So I'm going to rewrite that. I'm actually going to go back to one of my earlier things, and I'm going to slides, and I'm just going to clear this because I need more space. I'm out of space. X plus b over 2a equals, and I know you have this in your notes, but I'm going to recopy it for us. B squared minus 4ac all over 2a, because I square rooted the denominator and got the perfect square out. Or the factor of the perfect square out. Okay, so I am very close to getting x by itself. I just need to move this number away. I know it doesn't look like a number, but it would be a number if it was a normal problem. So I'm going to subtract it. I'm going to take b over 2a and subtract it from both sides. That will clear it out on the left side, and it will give me one more fraction. Now, here's the great thing. Plus or minus the square root of b squared minus 4ac is all over 2a. The denominator is 2a. Now, I'm subtracting another fraction that has a denominator of 2a, so I can just put it together. Basically, it's plus or minus the square root of b squared minus 4ac minus b, right? Because I'm just subtracting b over 2a, all over 2a. I'm just taking the two fractions, putting them together, just like I would if I had 4/3 minus 2/3. I'd just say 4 minus 2 is 2, and that's how many thirds I have left. That's what I'm kind of doing here. This looks kind of good, but I don't know about you. I find it very confusing to put a square root and then minus b, because then I'm like, is that under the square root? Is it out of the square root? I don't really know. It's supposed to be out of the square root. So maybe just for simplicity's sake, we should put it to the front so we don't get really confused. Because it's very easy when we're getting used to a formula to misinterpret it if it's not written clearly. How do I know that? Because generations of math students before you have done it. So we're going to put the negative b at the front, and then the other term, plus or minus the square root of b squared minus 4ac, and then they both have, of course, the denominator of 2a. And that should be the answer for what? X. Any x solutions for something of the form ax squared plus bx plus c can be solved using this random formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. What is that? Oh my goodness, it is the quadratic formula. We have just proven that the quadratic formula works. Not just sometimes, but anytime you have something of the form ax squared plus bx plus c equals 0, which happens to be a possible form for any quadratic equation. So, this is really helpful. That is the end of Part A. I will say before I start Part B that the important thing here is, well, there's two important things. One is, be amazed that math did not come out of thin air. Somebody proved every single formula at some point in history before you had to memorize it. So somebody didn't just come up with it because they thought it was fun. They proved it. They came up with some tricks, and they said, hey, now I know how to come up with a formula that everybody can use. So whoever that person was, I actually don't recall off the top of my head who it was. Maybe we don't even know. I don't know. I should look that up. But somebody did that so that you can use it. So you don't need to remember how I got the formula. But my second thing, besides thinking that math is kind of beautiful and that's really cool that we can prove things, the second thing I want you to know is we do need to memorize the quadratic formula, because if you don't memorize it, you have to recreate it every time. And who wants to do that? That's a gigantic waste of time. That's why we don't complete the square very often, because it's kind of a waste of time. We have an easier way to do it. But you can't use the easier way unless you memorize it. So I don't care if you have to say negative b plus or minus the square root of b squared minus 4ac all over 2a every night before bed to yourself. But I want to make sure that you can remember it when we have a test. Without a note card, without any extra support, that's something you want to say. And we will say it together over and over again in class, just so that we get used to the rhythm, get used to memorizing it. But I need you to be invested in that process as well. Okay, that is Part A. You may pause the video if you would like. Take a little break, go get a drink of water or something, and then come back because we are going to be working with Part B. All right, Part B is we are going to talk about square roots, because in order to use the quadratic formula, we're going to find ourselves using square roots kind of a lot. Because there's that part of the equation that says, let me actually show you, take this off here, that says that we're finding plus or minus the square root of plus or minus the square root of b squared minus 4ac. So right here, that may end up being a perfect square number. Like maybe it will be plus or minus the square root of 36, and it will very easily be plus or minus 6, but not necessarily. Let me show you an example. So we have x squared plus 10x equals negative 5. And we're going to use the quadratic equation, or the quadratic formula, to solve this. In order to do that, we need to put it in the master form of ax squared plus bx plus c equals 0, which we don't have quite yet. Right now we have our ones place over on the right side, so we're just going to move it over. And the significance of this is, of course, that we based our quadratic equation proof on the idea that a, b, and c were taken from a quadratic equation in this form. So it has to equal 0 or the quadratic formula will not work. Yes, it will if it's a 0. No, it won't if it's not. All right? So remember that. It has to equal 0. Now we decide on our a, our b, and our c terms, which in this case, a is 1x squared. I'll write a. B is positive 10, and C is positive 5. And we are going to plug this into our equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. So that would be negative b would be negative 10 plus or minus the square root of b squared, that would be 10 squared, minus 4ac, that's 4 times 1 times 5, all over, and that really is everything, including the 10, because remember we put those fractions together, all over 2a, so that's 2 times 1. And if I simplify this down, I get the solution negative 10 plus or minus the square root of, this is 100 minus 20, right? So 10 squared is 100, 4 times 5 is 20, so 100 minus 20, that happens to be 80, all over 2. This plus or minus means the same thing here that it's meant in our other problems in class. It means that we need to solve it twice to get both of our answers. So it could be that the answer is negative 10 plus the square root of 80 all over 2, or it could mean that it's negative 10 minus the square root of 80 all over 2. And we can take those numbers and we can put them in our calculator. And let me see, I figured them out ahead of time. The one on the left with plus square root of 80 comes out to be approximately negative 0.53, so negative 53 hundredths. Or the solution could be to the one on the right, the one with minus root 80, and that comes out to approximately negative 9.47, so negative 9 and 47 hundredths. So here's my, in case you didn't know this already, or if you had forgotten, that's my symbol for approximately equal. We make little wiggly equal signs, which means equal but not quite, almost equal to that, because I've rounded it, obviously. Why did I have to round it? Well, that's what we're here to talk about. I had to round it because of the square root of 80. Square root of 80 is not a perfect square. So it means that well, given what we know at this point, we probably just have to put it in our calculator. Or we could just leave it as the square root of 80, which is not really a problem. But the square root of 80 is not really a meaningful number to us, so leaving it there kind of looks messy and is not so helpful. So we're going to discuss the best way to take square roots and break them into pieces. All right, so let's go back here. I'm going to erase this. I'm going to go through, give me a moment here. We're just talking through so many different things. I'm just clearing them out. I know that's probably looks just crazy for you from your lens. I'm going to keep this one up though, so that we can refer to it. Okay, but square root of 80. Let's discuss the square root of 80. What the square root of 80 asks us, of course, is it's saying, are there two numbers that we could multiply together that would give us 80? Because if we could, like say in the number 25, we were looking at the square root of 25, we'd say what times what equals 25? Well, 5 times 5 equals 25. And a square root is kind of like a division sign for factors. Now, it's not division, right? Square root does not divide something by 2 or divide it by 3, but it takes the factors of the number. So in this case, 25, the factors are 5 times 5, and it breaks them in half. So it says, take half of these away and keep the other half. So the square root of 25 is 5. This works for anything, even like the square root of 100 over here. We could say that the factors are 10 times 10, but I want us to be thinking not about just like what numbers could be equal to each other, but I want us to think about what we call prime factorization, which is breaking it down into the smallest pieces possible. Like 10, we could break it into 2 times 5, and the same thing here. 10 could be 2 times 5. What that means is 100, sure, it's 10 times 10. 10 times 10 is 100, but it's also true that 100 is 2 times 5, which is 10, times 2 again, which is 20, times 5, which is 100. So I could say 100 is equal to 2 times 5 times 2 times 5. Well, what is the square root of 100? Well, it takes the factors, splits them in half, it keeps 1 2 and 1 5, and gets rid of the other half. So the square root of 100 is 2 times 5, which is 10. Now, you're used to saying the square root of 100 is just 10, but I wanted you to realize it's actually the square root of 100 is 2 times 5 because we take factors and we break them into pieces. We keep half and get rid of the other half. That's what a square root does. Where we end up with trouble is when you have a square root of a number that doesn't break into equal pieces. The square root of 80 is a great example. Let me show you how. I'm actually going to continue this on a different page because I don't want it to get too squished. So if you have a square root of a number that you don't think has equal factors, what I want you to do is practice doing prime factorization. Now I'm going to talk this through. I just showed you prime factorization, but I'm going to talk it through as if you've never heard it before. Prime factorization says we look at the number and we decide what the smallest prime number is that we think it's divisible by. Now remember, the smallest prime number is 2 because a prime number is just multiplied that number by itself. So this 2 only has 2 factors, 2 times 1. So it's the smallest prime. The next smallest prime would be 3, and then it would be 5. And then we'd move on from there, 7, and so on. But we tend to start with 2 or 3. And so I'm asking myself, the number 80, is it divisible by 2? Well, sure it is. It's an even number. So I can definitely break this into pieces. 2 times 40. Okay, so this can't be broken down any farther. But what about 40? Well, 40 can be broken down. Actually, it's divisible by 2 again. 2 times 20. Okay, this 2 can't be broken down any further, but the 20 can. 20 is 2 times 10. Done here. 10 can go one step further. It's 2 times 5. Almost ran out of room there. Can 2 be broken down any further? No. Can 5 be broken down any further? No. So I have just found the prime factorization of 80. Now I bet you've all done this at some point back in the day, but it may have been a while. So this is your process. Now here's what I've shown. It means that 80 is the same as 2 times 2 times 2 times 2 times 5. And if you don't believe me, that's fine. You can go and prove it in a calculator, or we could just do it here. 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 5 is 80. If you don't believe me on that, you can double check. 16 times 5 is the same as 8 times 10, and we know that is 80. Okay, so it works. 80 is the same as 2 times 2 times 2 times 2 times 5. Now, what again is the definition of a square root? Well, a square root takes factors and it breaks them in half. Well, I can do that with the 2's, right? There are 4 2's. That means the square root should say, let's keep these 2 2's and let's get rid of those. That's half kept, half gone. That would give me 4 as an answer. But I still have 4 is not the square root of 80. Why is it not the square root of 80? Well, because I actually have another factor here. Poor guy, he's trapped. He doesn't have a partner that he can cancel with so that he can be kept. So what happens is this 5 gets stuck in the square root. You can't split a 5 into pieces, so the square root is done. The square root can't split 5, so 5 stays in. The 2 2's come out. So we end up with 4 times the square root of 5. Now, if you are interested, you can actually take the square root of 80, which happens to be, I wrote this down, what is the square root of 80? I forget. It is approximately 8.94. And if you take This 4 times the square root of 5, you will also get approximately 8.94. They are equivalent expressions. That is what a factor, a square root does to factors that don't split evenly. Let me show you a quick way of saying what I just said again. If I have the square root of any number with perfect square or non, we're going to use 80 again, I can use the factor tree to break it into pieces until it looks something like this. And the rule that I like to teach, I'm going to re-say what I just said, but with a funny little narrative with it, is that we think of the square root like a jail for factors. And in jail, it's a lot easier to escape from prison if you have a buddy to get out with you. So here's our sad and rather morbid tale. The tale is that if you have a factor with a buddy, then they can escape from prison, but only one will survive. So they get out together, one gets out, the other gets shot. It's really sad. It's a really morbid story. But 1, 2 did get out, so that's good. Sad, sad tale. All right, let's retell this sad tale again because we still have 2 buddies in prison. One can get out. They got to get out together. One gets out. The other is dead. So we get 1, 2 out, another 2. And so long, other 2 factor. 5 is left inside jail. He wants to get out, but look, he has no buddy. So he is, unfortunately, stuck. What is the answer here? 4 square roots of 5. So that's one of the most morbid tales in math, is the story of how factors get out of square roots. That works though, and let me tell you, everybody remembers it. So when we get square roots in our answer, like in the solution to that problem earlier that had, I don't remember, -10 plus or minus the square root of 80, we can take those numbers and find the decimal value, but we will always lose accuracy. So instead, now that you're in Algebra 2, I'm going to request that every time you have a square root in your answer, you take that number, break it into factor pieces, and then I hear Mari in the background, and you probably do too. We're going to try to ignore her for a second here. Let me try to regather my thoughts. Every time you have a square root, you want to break it into its factor pieces, and then you want to simplify it. That's actually the process. Simplify it by pulling out the ones that can come out and leaving the other ones in that can come in. All right. That is all for section B. I am certain that you need to do more work with this, but if you have those models in your notes, you're going to be prepared to do some of our example problems when we get together in class. All right, for time's sake, let's stop it there, and I will see you soon in class.